So let's say we have this graph of f of x, and we have 2 points A and B, and we need to find the area beneath the curve from A to B. This is going to be called the definite integral, which is just the area under a curve from with the interval A to B. And you already know how to approximate this using Riemann sums by drawing rectangles with equal length like this. But today, we're going to find out how to find the exact values of this area under the curve. And the notation for this is going to be this. This is going to be like an S with a, b, f of x, dx. And again, your a is your lower bound, the lowest value. Your b is the upper bound, your highest value. And you're trying to find the area between a and b. F of x is your function, and dx is just the change in x. This is how you notate your definite integral. So, for example, if you had f of x is equal to x cubed, and you wanted to find the area from the interval 1 to 3, then you would write this s 1, 3, x cubed dx. And we can actually use the Riemann sums to come up with a formula for definite integrals. So let's say we have this number of rectangles, just any number of rectangles. And let's use the right rectangle approximation method where you draw them from the right. And so it's going to look something like this. And let's say the number of rectangles you have is n. And so that means like when you sum up all these rectangles, we can use sigma notation where I equals 1 to n, the number of rectangles, of f of x I. What this means is that like for the first rectangle, you're going to be calculating the value at this point, f of x at this point. This will be f of x1. This will be f of x2. This will be f of x3. And then your last rectangle will be f of xn, or the number of rectangles you have. In this case, it's 4. All of this multiply your width, because you have to multiply the y value by your width, which will just stay the same the entire time. Like we discussed in a Riemann sums video, you can just multiply this by the sums of all your y values. And if you think about it, the more rectangles you have, the more accurate your estimate will be. And if you have infinite rectangles, then it's going to be a perfect estimate. So for a definite integral, a formula can be limit as n approaches infinity of your width times I equals 1 and sum of f of xi. This can be a formula for definite integrals, and we don't really use this formula pretty much at all, but this is just kind of conceptual. The more rectangles you have, the more accurate your estimate for the integral will be. And you can just use your calculator to test like 500 rectangles or like 1,000 rectangles using the left hand and right hand approximation methods. So you can approximate your definite integral and probably even find the answer if it's simple enough. Now let's do an example of a definite integral. So let's say we're supposed to find the area of 1 plus 4x from 1 to 3. So which means let's draw a graph of 1 plus 4x first. So it's going to look something like this. And we're supposed to find the area from 1 to 3. So it's going to be kind of like a trapezoid. And you can just use the formula for a trapezoid. But what I'm going to do is I'm just going to separate this into a triangle and a rectangle. And what we can do is we already have the width for both the triangle and the rectangle, and we just need the heights. So for the height of the rectangle, if you think about it, it's just going to be f of 1, the y value right here. So f of 1, and we're assuming f of x is this, by the way. It's going to be 5. So the height The rectangle is going to be 5, and the area is going to be 10. And for the triangle, what we can do is to find the height of this whole part, this is just f of 3, because that's the y value right here. And if we find this, subtract 5 from it, then we just get this part, which is what we need because that's the height of the triangle. So f of 3 is going to be 1 plus 4 times 3, which is 13. And 13 minus 5 equals 8. So the height here is 8. And to calculate the area for the triangle, we just do 8 times 2 divided by 2, which is 8. And now we add up our areas together. It's going to be 18. And that's our final answer. Now, let's do a practice problem. If you think you know how to do this one, pause the video and try it. This problem has to find the area of 2 minus x from -1 to 2, with a definite integral from -1 to 2 of 2 minus x. So what we can do is first, as always, we draw our graph, 2 minus x, which will look something like this. And from -1 to 2. And let's find the area of this, which is just going to be a triangle. First, we don't know if it's going to be a triangle. It could be a trapezoid, or it could be something like 2 triangles, because we don't know where 2 is. So let's see what f of 2 is. So f of 2 is equal to 2 minus 2, which is just 0. So yeah, since f of 2 is just going to be on the x-axis, this is just going to be a triangle. But if f of 2 was like up here, it would be a trapezoid. If f of 2 was down here, it would be 2 triangles. But we got lucky, it's just on the x-axis, so it's just a triangle. And we already have our width. It's from -1 to 2, so you can just count. So the width is 3. And to find the height, we just need to do f of -1, which is just 2 minus -1, or 2 plus 1, which is 3. So it's going to be 3 times 3 divided by 2, which is 9/2. And that's our answer. Now, let's do another practice problem. And I'll give you a hint for this one. This is a function for a semicircle. And if you think you can do this problem, then pause the video and try it. But this problem asks to find the area of square root of 4 minus x squared from -2 to 2. And as I said, this is the function for a semicircle. If you don't know why, well, let's say formula for a circle is x squared plus y squared equals radius squared. So y squared will be equal to r squared minus x squared, or y equals plus or minus r squared minus x squared. And if this is for a full circle, so for a semicircle that's on top of the x-axis or above the axis, we get rid of the negative, so it's positive, we just get rid of that too. So yeah, so if this is the formula for a semicircle, then that means our radius is going to be 2, because r squared equals 4, so r equals 2, and that checks out because the diameter of our circle is from -2 to 2, which is 4 units, or that means our radius is 2 units. So let's draw our circle. It's going to be like this, from -2 to 2. And so for the area of a circle, it's going to be pi r squared. But for a semicircle, it's divided by 2, obviously. And we have our radius, which is just 2. So radius squared is 4 pi over 2, or just 2 pi. And that's our final answer. So everything that I explained in this video, and all the problems that I went through, should teach you about an introduction to definite integrals. If you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.